Hi everyone, welcome back to my channel. So in today's video, as I promised, I will go through the knife Bayes algorithm, how it's working, and I will provide you with, explain it with a simple example and along with the Python code, with the pure Python and also with the scikit-learn. And if you, let's go to this document here. Now you can see this is the prepared document with example, and I try to make it very easy for you to go through, or let's say to understand the basic or the goal behind knife Bayes. So as you can see, it took a lot of time for me to prepare this. If you like this video, please subscribe and like the button and hit the button. And if you have, of course, any question, just write it down in the comment below. Okay, so here you can see the knife Bayes. It's a classification. It's a supervised learning algorithm used to classify the data. And as you can see here, for instance, I have these shapes, and I will try to calculate. I will try to classify all these shapes into a different groups. Let's see different classes here, as you can see, based on the probabilities. And you can see knife Bayes is a probabilistic machine learning algorithm based on Bayes theorem. It's assume all the features are independent given in the class label. So the main, let's say, assumption or the for the knife Bayes is they said all the features are independent from each other, which sometimes it's not the case. So for example, time series, each parameter, it depends on the other. And what is the this equation here? So it's like the what is the probability of x to be in y? Let's see. And this is called posterior probability. This is the likelihood. What is the probability of x? Let's say the likelihood of x to be in y. And this is the prior probability of the class label here by y. And this is the evidence. And everything will be clear with the example. Don't worry. So you can see here, this is the equation, and the pi y of x, it's the probability of y given features x, and this is the probability of x occurring in y. What is the probability of, let's say, of x? That will should be in y, and the probability of class y in the data set, this one here, and this is the probability of x across all the classes. So yeah, sometimes the text is not clear, but with the example you will understand it 100%. So types of naive Bayes are classified. It's Gaussian naive Bayes for numerical, and this is for text classification, multinomial Bayes, and spam detection, and also for binary classification. So let me just see. I have this data set here, right? And this is, you can see, if it's sunny and the temperature is hot, high, the humidity is high, the wind is weak, so play tennis, no. So this is, let's say, a small data set. So it's not like, let's say, a decision tree, for instance, or let's say any other algorithm, for instance, linear regression. For in a linear regression, we try to find the best fit, or let's say the best parameter that can fit the data into a line with minimal distance. Oh, by the way, you can refer to the this lecture as well. And for this here, we will not, let's make it a simple. We will not build a model. So for instance, in a decision tree, we try to construct the tree, and once we have the uh, a test example, it will just go through the tree. But here we will, it's not like this. It will just, as you can see here, this is my text data set. And I would like to classify, for instance, this text, this column here. So for instance, its outlook is sunny, cold, high, strong. And what is the best, let's see, or the right class label or play tennis? Is it yes or no? So we need to calculate this. So based on this, as you can see in the beginning, we have to calculate the prior probability of classes. yes or no. For example, we have here two classes, yes or no. So total number of classes are 14. Instances with lateness is yes 9 and no is 5. And you can see calculate the probability 9 divided by 14. This is the probability, and for the no class is 5 divided by 14. So this 14, as you see, this is number of instances. All of these instances, 14 sample. Now we need to calculate the likelihood for each feature. So the likelihood is this one here. Let's see for the features. I have seen the feature is outlook, temperature, humidity, and wind. For the uh, for the let's see outlook, the class 1, 2, 3, 4, three classes, three yes and one is no. As you can see, for instance, if we go to only out for the sunny, let's say go to the sunny, it is I mean outlook, number of outlook, it's 9. Sunny with sunny, for instance, 1, 2, 3, 4, 5, 5. Okay, I think I have made a mistake. Oh, no, everything is fine here. Okay, so let me just show you this. So you can see for the outlook, I will start with sunny. So you can see this sunny, this one here. Okay, this sunny here. It has yes, no. For instance, I have only yes, 1, and also this one here, 2. So that's, you can see 2 divide by 9, number of yes is 2 divided by 9. And for the overcast, so overcast is 4 is yes. You can see 1, let's start from here, 1, 2, 3, 4. And all of these 4 are 4 cases. I mean, yes. So it will be 4 divided by 9. And raining, it will be 3 to divide by 9. And let's see to sunny. I mean, as you can see, rain and overcast, uh, it's 9. And let's see, go to sunny. For the sunny, it's no. With the sunny is 1, 2, and 3. So 3 divided by 5, number of no classes, let's say instances. And for this, you'll try to see sunny is yes, cold yes, high yes, strong yes, and also the probability of yes. So then for the sunny, yes. I mean, this is for the first example. Let's see, sunny yes. Not for the first example. Sorry, for this one here. For this example, let me just move it down. And you can see for the sunny. For the sunny, I have 2 of the sunny are yes, divided by 9, number of classes, and multiplied by cool. Cool, it equal yes. You can see, for instance, cool for the other parameters 1, 2, and 3, cool, and etc. for the other classes, for the other, let's see, attributes. And the probability, sorry, this for yes, and the probability of yes, it's 9 instances over of 14, and the probability of yes, it will be this one here. Now we will try to calculate the probability of no. It will be for the sunny know how many instances. It will be 30 divided by 5. If you go to the data set, the sunny is no, belong to no class is 3. For instance, 1, let me just go to this, 1, 2, 2, and it should be 3. 1, 2, and 3. Yeah, 3 instances of the sunny is no. 3 divided by 5, 5 number of classes, and also multiplied by all of this. This is the probability of y of no class. This is 5 divided by 14, and this is the probability. Now we need to compare the classes, the probability. You can see which one is the greater the maximum. So for instance, this is the maximum one here. So we will assign this class. So assign the play tennis to no class. So this is in the beginning we have said we need to classify this table, let's see, or for data. And as you can see here in the naive Bayes, we don't calculate, let's see, we don't construct, let's see, a model. It's just calculating on fly. And let's see what is the advantage of naive Bayes. It's, as you can see, it's nothing. It's just super fast, efficient, and work also for big data, for large data set. It's not like KNN. You need to compare all the instances and all the features of the training and calculating the distance through the whole data set. And also this is, you can read it, and the disadvantage of this is strong independent assumption. They said this features here, for instance, is all these features are independent. This is let's see, the assumption, which is not right for the whole data set. And for the implementation, I have added here naive Bayes. So I have in the beginning I have implemented with pure Python, and what if you run this, you will get the same data set as in the document, and plus the scikit-learn. So for the scikit-learn, let's say for the big data set, if you would like to use it in your projects, or I recommend you to use this part here, not the above one. So this one here is only for you to let's say to understand step by step and debug. And let's say this is not optimized as the scikit-learn. This is, I will say, this is my feeling. And yeah, so also this will be attached in the document, in the Git repo, so you can see it's already here, naive Bayes, and you can see this is the document. Yeah. And as you can see, this preparing this lecture, it took a lot. It took time for me. So if you like it, please subscribe and hit like button. And if you have, of course, any question, just drop it down in the comment below. Thanks for watching, and see you next time.